Let's talk about the actual design for this note graphing synth that I've created for the Electra One MIDI controller and EaganMatrix, interfacing to a Hawken Continuum or an Expressive E Osmos, possibly a Hawken EaganMatrix module. In particular, this video will talk mostly about creating the EaganMatrix preset that's the core of the overlay interface. Now, from the Electra One perspective, and you could create overlays using different controlling interfaces. It could be an iPad application, a Windows application, could be a lot of things. I choose the Electra One because I like the tactile feel of it being almost like a Eurorack module. One of the things I like is that the Electra One gives you this nice GUI builder tool so you can prototype your interface before you do anything. Once you have an idea, before you even create an EaganMatrix preset, you could go in and create a prototype GUI to let you have a little bit of a feel for what your application is going to look like. But this Electra One application is nothing unless you create the EaganMatrix preset that it interfaces to that actually creates the sound and does the work. Now, once you created your GUI interface, then you can implement it and create the actual interface. But again, this interface has to connect to your EaganMatrix preset and manipulate its controls to do anything. Once I have the idea of what I want to do, I can prototype the GUI, but then I have to go in and write the EaganMatrix preset to do the actual sound generation and control functions that are required for the overlay. Now we'll talk in a bit about this particular EaganMatrix preset. You can see it's got a reasonable amount of stuff in it, but it's not overly complicated. At the core of this is the use of two note graphs. This is a relatively new feature that was added a few years ago. This takes the original graph that's using a bit graph to define dB offsets for certain sonic functions in the EaganMatrix. It lets you redefine the values as MIDI note, and then you can use a shape generator to index through these notes at a certain speed to create basically a sequencer, which is what this overlay does. And then you can take these values and pass them through a note to kilohertz conversion interface in the EaganMatrix, and that you can send out to create your sounds as the X input to oscillators or other sound components in the EaganMatrix. Now, since you can have up to 48 notes in a graph, and you can have two offset graphs, the main graph is set to 0, so each one of these offset graphs can actually be used to create a separate independent voice, each playing its own set of notes, so to speak. And the Electra One interface, because I can only have 36 controls on a page, I split it so that there are main controls for a voice on each page, voice 1 and voice 2. Voice 1 manipulates the offset graph 1, voice 2 manipulates offset graph 2, and the first 24 notes are on the first page, the second 24 notes are on the second page. Then there's a control to switch between the two voices, and there are other controls we'll talk about. That's the main idea behind this preset. We'll talk about how you actually program the graphs in a bit, but the preset needs a lot of other functions for it to operate as expected. I need formulas that output the two voices, so I have a volume formula for each of the voices. I allow you to have a solo instrument you play above the sequencer graphing pattern. For that, I define two oscillators, basically a phase generator and a wave bank. So I'll have separate volume controls for each of those two in my EaganMatrix preset. I'll add some convolution and allow you to do some convolution programming in this preset. So there's formulas for that. There are the formulas for the two main oscillators for voice 1 and voice 2, which outputs the sound when you index through the graph. Then I have two oscillators that are used as modulating sources, and those are sent into the two main oscillators. So I'll have formulas that do the modulation, then I'll have a formula that controls the solo voice, the phase generator. I'll have formulas that control the wave bank, the other solo voice. And then I have some formulas for shape generators, the formulas that index through the two offset graphs, and a shape generator that controls some dynamic morphing, some dynamic indexing through the convolution, so you can apply a shape and an automatic output of a changing convolution based on a shape. And that's it. So the preset itself is not overly complex, but what I can do in it is very complex because I have so many different controls and other options that can manipulate this graph in many different ways. How you create the graph, whether you do it by inputting specific notes, or I have options to generate the notes of these graphs automatically, creating 12-tone rows based on some random generation. Then I have a composer feature that lets you set distributions on notes and durations and other things to automatically create a graph for you, like a little composer. All those things are kind of internal to the Oerlay application, but the actual EaganMatrix preset doesn't really do that much. So you're really only limited by your imagination in your application in terms of how you can manipulate the controls in your preset to do different things. Now, in the old days, before the overlay interface was added, I could still do something like this, but the old interface only allowed 6 macros, 6 7-bit macros to be controlled externally. So if I wanted to do a similar application before the overlay interface, I would be limited to only having 6 controls. Maybe the volume controls for each of the outputs, and maybe indexing speed control, for example, for the 2 voices, but that's all I'd be allowed to do. But now, with the new overlay interface that allows you to define up to 90 14-bit controls, so you not only have a lot more controls, but you have more resolution on the controls, I can now assign a lot of different stuff in this overlay to control all of my formula values. And in an overlay, that's not uncommon. You'll most often have controls set to almost every formula so that your external overlay application can allow you all this new and wonderful control. As you can see here, the preset is kind of limited. I only used the first original 22 formulas. If I wanted to, I could have expanded this more, and I have an additional 22 formulas still available in this case. But this overlay is more dependent on how externally I create and manipulate these graphs than anything else. And I don't need a lot of internal formulas to do that. Now, once I have the idea of this thing created, and once I create my EaganMatrix preset, I will assign all of my macros to that. And then when I create my overlay application, I have to map the right controls to the right 14-bit macros. And if you don't create some kind of documentation for yourself to know what all these things are, you can get very confused very fast. So when I create these applications, I also always create a spreadsheet or a table of what are the macros that I'm using, what they do, and what their numbers and interfaces are, and what their formulas are, because some of these controls require formula pokes, as it's called, to know exactly what formula you're on to manipulate and program. So once I have all this stuff set up, and during the process of creating this, I might change things. I might add formulas, I might add controls, I might take them away, experiment as I go through creating the overlay. Once it's all done, everything's documented, I'll create a document for the users on how to use this stuff, and then we're off to the races. So now let's talk about how we actually create that overlay preset. Okay, let's take a look at the actual preset and discuss what the formulas do and how I've created the overlay interface. The first thing you'll notice is I don't use any of the standard macros. All the macros that I will use are the new 14-bit macros, and those are not going to be assigned to the normal controllers. So as we said, this preset, the core of it, is manipulating two offset graphs. On the left, you'll see your triangles that you can use to display and set graphs. Now, some of these have already been set with the program, but you'll see, as we discussed, there are 48 possible entries here that you can define as notes. The main graph is going to be all set to its minimum value so that when I apply the offsets, those can be interpreted as the notes that they are supposed to be, internally offset as I need to get the right MIDI values out. So the main two formulas that do this, for voice 1, oscillator 1, and voice 2, oscillator 2, they use identical formulas. I offset them in frequency. That is just something I do to get a better sonic output that I'll offset in my application to get the expected notes out. Let's look at the main formula that drives the pitch output for the oscillator. You'll see that it uses a shape generator 1, which is set to a speed and triggered with W, triggered with your normal gate, key gate on an Osmos or fingerboard gate on the continuum. And that will cycle through 0 to 48, offset by 1, to go through my 48 values of the graph. And you'll see in the ancillary, I define integer offsets for the W operation, and I translate that integer offset into note value to kilohertz conversion. So in effect, what this does is it cycles through the graph, it outputs the values, converts them from MIDI note numbers to kilohertz, and that's how I basically create a mini sequence. Voice 2 does exactly the same thing, only on a separate set of formulas, so I can have independence of voices for those two graphs. Also, the main X component that drives the note graph, you can see I use a blend that increases as you bring up macro M10 that you program, adds both persistent, sustain to the output of that graph, and also adds interpolation. So it adds a glide portamento function that increases as you bring up this M10 macro. The oscillator is set with a timbre control, spectral balance, and you'll notice the timbre control has M11, macro 11 assigned to it. So my application running on the Electra One, when it changes macro 11, it will change the timbre of this from 0 to 0.5. Just the value that I wanted the timbre to change, because I allow you modulation input as well. Same thing happens on the second oscillator for voice 2, only that uses M14. So as you see, almost every formula here has some macro assigned to it, so I can have external control from the Electra One, or whatever your controlling interface is, to control each formula to do different things. So I have timbre control, I have speed control, because the speed of each of these shape generators is controlled by a macro. The range that I index through the graph is controlled here by macro 9. So if I set that low, I might only play the first 10 notes of the graph. Or if I set it on the controller to its maximum value, I'll go through all 48 notes of the graph. So that allows me to manipulate how many notes in the sequence I will play in my iteration, because this is a continuous shape generator. Once you set a note or notes for the graph or the sequence in your controller, the sequence is just going to iterate over and over and over again. And if you change the notes as it's iterating, or you load another graph as it's iterating from your application, things will instantly change to the new sequence note output, which is nice. Pretty simple. Two oscillators playing note graphs. Then I have formulas that control the output volume of each of those two oscillators. I'll have a main macro that controls the volume of that. I'll have a macro on Y, because if this is an Osmos, I want to be able to get volume output through the full key press. This is how I can create a preset that is both running on a continuum and an osmos. On continuum, you just wouldn't set this macro, and Y will always be 0, and it would be just like you're normally using Y in a continuum. That would not apply to volume. If you're on an osmos, you can set your Y to some value, either maximum, or if you don't want Y to have so much increase in volume, you can set your M29 on your application to less, and in this way you can have one preset be used for both continuum and for osmos. Doesn't always work that way, but in this case it does. And I scale the output volume on pressure. Then in addition to that, I have a blend that will add persistence on the output as you bring up M30. So if you want, you can get a little sustain on the output with that control, assuming you apply it in your application. B is the same exact formula as A, only that applies to voice 2. Then I have two oscillators, one a standard oscillator and one an integrated oscillator, and those are used as modulating inputs to the two oscillators. Those use the same formulas as the main oscillators. It just works out, if you do that, you get a very nice change in modulation, a real kind of gutsy change in both timbre and in frequency. Now you could choose to modulate a little bit differently, but I just chose to do it this way for this preset. So those two oscillators are sent as modulating outputs into the two main oscillators, and I have controls for the modulation inputs on those two oscillators that again use different macros. So in my application on the Electra One, I can have a modulation control, and all that's going to do is change the value of M18. So you really have two main types of control from your application. One type of control is just incrementing a macro value that's placed on a formula. That's pretty easy. The other type of control in your application is you're actually doing something creative, something different, like creating a 12-tone row. There I have to create all those values in the application, and then I'll send them down to change the graph using a poke that is supplied to change graphs. That's really more the application programming part of it. That will be another video. So we have the two modulation inputs. We have now two oscillators that I use to allow you to play a melody above your sequence. There are other pokes you can use to basically split your output so that the range of your voice output is not always all to all. I can change that so that I can have the main voices output, say, C0 to B4, and then I can change the outputs on my solo voices to start at C5 to, say, C9. So I can actually create programmed splits of this nature using pokes that are defined in the overlay interface. So I have these two separate oscillator types that are used for the solo voice that are basically output mixed together, a phase generator that you can change the phase type on in your application with some pokes, and I have a wave bank that also is used as a doubling solo voice, and those you can use pokes to change the waveforms if you like, that I actually allow you to do. So I'll have a standard X formula used for pitch, the spectral balance, that the timbre of my phase generator is controlled with M21 in my application. This is very simple programming. It's just I have all these new macros that I can assign. Then I have my wave bank, a very simple wave bank that I have unity amplitude set on that. I'll have a few waves defined, and one of those I'll set down an octave. I actually allow two offsets here, one that goes up and one that goes down. That gives you a very nice frequency offset option that I have in the application here. Setting M27 does that for you. One formula goes up, one formula goes down. And then on the wave bank, I have the duty cycle set that will change timbre on this, and that's set with M22. Very, very simple EaganMatrix programming. The complication comes with all the application interface that you apply to do different things here. Then I have my shape generators. As we said, the indexing through of the first oscillator is done with shape generator 1. The formula on that is controlled by M15. So if your application sets M15, it'll set the speed that indexes through the sequence for voice 1. Same thing. Formula H sets the speed using M16 that will index through voice 2. Then I have my convolution controls. So I have the ability to change your IR selection in the application to any of the IRs now available. You can change all 4 convolutions. I set this to go through a base index from 0 to 2. You can go to 0 to 3, and what I allow you to do then is I put Y going 0 to 1 to fulfill the full 0 to 3 range, so I can get extra aftertouch effect on the Osmos using the normal aftertouch on Continuum using just forward to back Y motion to allow you extra convolution timbre change on Y. So that does give you some aftertouch effect. I don't really use too much Y aftertouch effects in this at all. You could choose to do a lot more if you wanted to. Now, when you use convolution controls, you have to set your use touch control area or the convolution programming won't work as expected. So I have indexing for the convolution. I have mix for the convolution. Your wet to dry amount. If it's 0, no convolutions applied. If it's set to 1, you get 100% wet convolution. And M24 in your application controls the convolution mix. Then I have a shape generator, which you can set in your program using a poke to one of a number of different shapes that will go through the full range of your convolution, 0 to 3, using whatever shape you define with this third Shape Generator 3 option. And what this allows you to do, if you set this in your program, if you set the speed to 0, nothing will happen. It won't trigger. But if I set a speed on this third shape generator now, it'll start cycling through using whatever shape I define in my program, the convolution, and that will give you dynamic timbre change through whatever the 4 convolutions that you have set. Now, if you want to, you have a range here on M26 that you can set on that convolution so that you don't go through the full 4 convolutions. If you set this to say only 1, you'll only go through the first stage of the 4 convolutions. That allows you to get more control. So I can have the speed and the range of the convolution applied here. And that's pretty much it. It's a pretty simple program. If you want to, starting out creating these things, the simplest thing to do is just to take an existing preset and modify it, add extra controls to it, and write an application to interface to it to do more than your original did. One thing to just be aware of, Osmos presets can get pretty complex. So doing this to an Osmos preset that already normally might use most all formulas can be a little bit daunting. So if you're going to want to take a preset to modify initially, to add some controls to, I suggest you take one of the simpler Continuum presets to start with. So as you can see, this is not really difficult programming for doing overlays. In fact, in general, overlay presets typically tend to be a little simpler than complex ones that don't use overlays because you have so much more complexity that you can apply through your overlay application now. You don't have to try and do so much in the EaganMatrix preset itself, but you do have to assign all these macro interfaces to it so you can apply all those controls from your overlay application. So that gives you a little bit of an idea of how to create this overlay preset. Next video, I'll talk a little bit more on creating your overlay applications. I have some videos on that already, but I'll create one that's specific to this in terms of how I program things that might be of interest to some.